What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-007 certification. So let's get into it. In this video, you're going to learn about wide area network services such as ISDN, T1, T3 circuits, E1, E3 circuits, OC3 and OC192 circuits, DSL, Metropolitan Ethernet, cable broadband, Dialup, PRI, and various transmission mediums. Talk about the first service type, ISDN, or Integrated Services Digital Network. So ISDN, this is a set of communication standards for simultaneous digital transmission of voice, video, data, and other network services over the traditional circuits of the public switch telephone network. ISDN is used on PSTN lines with a terminal adapter on multiple channels of 64 kilobits per second each, and a terminal adapter. This resembles a conventional analog modem. Internal modems plug into the same PCIe or PCI slot used by analog modems, and external modems are USB or serial ports. And there are two types of ISDN connections provided by local telephone companies, in which both types of connections enable the use of the internet, talk, or fax communications through a phone line at the same time. The first one you have is PRI, or the primary rate interface. So a PRI connection, this provides 1.536 megabits per second of bandwidth, whereas a BRI interface provides 64 kilobits per second or 128 kilobits per second dual channel of bandwidth. And PRI is also sold to large organizations. Then BRI, or basic rate interface, this is sold to small businesses and home offices before DSL and cable became widely available. And BRI, it offers up to 128 kilobits per second of bandwidth. Also, most telephone companies have largely phased out ISDN in favor of DSL, which is much faster and less expensive for internet connections. Then we have a T1 circuit. So a T1 carrier, this is a dedicated phone connection supporting data rates of 1.544 megabits per second. A T1 line consists of 24 individual channels, each of which supports 64 kilobits per second. Each 64 kilobit per second channel can be configured to carry voice or data traffic. Most telephone companies allow you to buy just some of these individual channels, which are known as fractional T1 access. And T1 lines are a popular lease line option for businesses connecting to the internet and for ISPs connecting to the internet backbone. The internet backbone itself consists of faster T3 connections, and T1 lines are sometimes referred to as DS1 lines. So when someone says they are running T1, they may be saying a few different things, such as they may mean that they have a network that is passing data at 1.544 megabits per second, or they may mean that they have a network that conforms to the T1 electrical interface specification, or that they have a network that passes data that conforms to one of the several framing rates such as D4, ESF, etc. But more likely than not, they mean all three, but their concentration may be only one of these items. And a T3, this is a dedicated phone connection supporting data rates of about 43 megabits per second. A T3 line actually consists of 672 individual channels, each of which supports 64 kilobits per second, and T3 lines are used mainly by ISPs connecting to the internet backbone and for the backbone itself, and T3 lines are sometimes referred to as DS3 lines. Next, we have the E-carrier lines, and the first one is the E1. So the E-carrier system, this enables the transmission of several multiplex voice and data channels simultaneously on the same transmission facility or line. Of the various levels of the E-carrier system, the E1 and E3 levels are the only ones that are used. An E1 circuit contains 32 channels, in contrast to the 24 channels on a T1 circuit. Only 30 of those 32 channels, however, can transmit data such as voice and video. Specifically, the first of those 32 channels is reserved for framing and synchronization, and the 17th channel is reserved for signaling, that is, setting up, maintaining, and tearing down a call. And E1 circuits also have a bandwidth capacity of 2.048 megabits per second, and E1 circuits, they are typically popular outside of North America and Japan. And just as a T3 circuit provides more bandwidth than a T1 circuit, circuit and E3 circuits available bandwidth of 34.4 megabits per second is significantly more than the 2.046 megabits per second of bandwidth offered by an E1 circuit. Next, we have OC3 and OC192. So optical carrier transmission rates. They are a standardized set of specifications of transmission bandwidth for digital signals that can be carried on synchronous optical networking or SONET fiber optic networks. Transmission rates are defined by rate of the bit stream of the digital signal and are designated by a hyphenation of the acronym OC and an integer value of the multiple of the basic unit of rate, such as OC-3. So OC-3, this is a network line with transmission data rates of up to 155.52 megabits per second with a payload of 148 megabits per second and overhead of 6 megabits per second, including the path overhead using fiber optics. And then OC192, this is a network line with transmission speeds of up to 9,953 megabits per second with a payload of 9,510 megabits per second and an overhead of 442 megabits per second. Let's talk about DSL, or digital subscriber line. And this is a communications medium used to transfer digital signals over standard telephone lines. Along with cable internet, DSL is one of the most popular ways ISPs provide broadband internet access. DSL is used by telephone companies to provide internet services at speeds much faster than that allowed by analog or dial-up internet services, while allowing traditional analog telephones and devices such as fax machines to share the same connection. To make this possible, devices called DSL microfilters are attached between telephones and telephony devices such as answering machines, voicemail, and fax machines to prevent interference with DSL signals. And traditional DSL runs over telephone lines originally developed for voice services only. It is far slower than a cable internet connection, and traditional DSL speeds range from 768 kilobits per second down to 384 kilobits per second up, all the way to 6 megabits down, 768 up. Speeds decrease as the distance between the DSL service location and the central office or the central switch providing the DSL connection increases. And most DSL providers do not have data caps. Some of the disadvantages of DSL are as follows. It has inconsistent internet connection speeds. It's available in limited distances from the service provider, and speeds drop the greater the distance from the connection to the internet, which is also known as, once again, the central office or the central switch, and it is slower than cable or fiber connections. Next, we have Metropolitan Ethernet. So a metropolitan area Ethernet, also known as Metro Ethernet. This is a metropolitan area network that is based on Ethernet standards. It is commonly used to connect subscribers to a larger service network or the internet, and service providers, they use Metro Ethernet to do the following things, such as interconnect business offices or data centers, where Metro Ethernet can connect 2 sites or hundreds of sites. It can connect residential subscribers or businesses to the internet. It can provide connectivity to public or private cloud data centers. It can provide wholesale mobile backhaul services, and it can provide multicast delivery used by business customers for video conferencing and used by residential subscribers for IPTV and video applications. Then we have cable broadband. So cable internet access, or simply cable internet. This is a form of broadband internet access which uses the same infrastructure as cable television. Like DSL and fiber, cable internet access provides network edge connectivity, which is also known as last mile access, from the ISP to an end user. It is integrated into the cable television infrastructure, just like how DSL is integrated into the existing telephone network. And data signals, they can be sent over a network in 2 ways, either by baseband or broadband. In baseband signaling, this sends a signal at any given instance, whereas broadband signaling sends multiple signals on separate frequencies. A single piece of coaxial cable carrying multiple signals comes into your home, and a small box enables you to select specific channels. Broadband creates these separate channels through a process called frequency division multiplexing. The term broadband is widely used to refer to high-speed internet access, and broadband provides users with an always-on, high-speed connections to access the internet and transfer data. Unlike narrowband, broadband does not tie up a consumer's phone line lines. Plus, it enables access to high-speed bandwidth applications such as voice and video calling, online video streaming, interactive gaming, and much more. Then we have Dialup. So Dialup internet access. This is a form of internet access that uses the facilities of the public switch telephone network to establish a connection to an ISP by dialing a telephone number on a conventional telephone line. Dial-up connections use modems to decode audio signals into data to send to a router or computer and to encode signals from the latter two devices to send to another modem. Until the late 1990s, dial-up networking was the most common way for home and small businesses to connect to the internet. Today, dial-up connections are used when no other internet connection is available. Dial-up has rates ranging from 28.8 kilobits per second to 56 kilobits per second and is available any place that has a landline telephone system. A disadvantage of telephone dial-up is that voice and data cannot share the wire at the same time. And then we have PRI, and this stands for Primary Rate Interface. So PRI, this is a telecommunications interface used mostly in an ISDN or Integrated Services Digital Network. A PRI is a form of time division multiplexing, allowing you to send up to 23 separate communications via voice, data, or video, and channels are typically used by larger enterprise companies with a PBX system to help with access to the public switch telephone networks. And then finally, transmission mediums. Now, we have already covered this topic where we discussed various wide area network transmission mediums such as satellite, copper, fiber, and wireless. And you can go find those if you look for my CompTIA A+ course. Look for video 2.7, which is titled Internet Connections and Network Types. And in summary, we have talked about all of this wonderful stuff pertaining to wide area network services such as ISDN, T1, T3 circuits, E1, E3 circuits, OC3 and OC192 circuits, DSL, Metro Ethernet, cable broadband, dial-up, PRI, and I told you exactly where you can go to find out more information about various transmission mediums pertaining to wide area network services. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Network Plus N10-007 certification. And until next video, ladies and gentlemen, peace.